more than 25 billion kilometers from Earth, far beyond the familiar orbits of the planets. A lone spacecraft from the 1970s is still transmitting faint whispers of data. That spacecraft is Voyager 1, humanity's most distant emissary. And now, it has encountered something both puzzling and awe-inspiring. A strange boundary in space where temperatures soar to between 30 and 50,000 degrees Celsius. Scientists call it the Firewall, but there are no flames, no flickers of light, just an invisible ocean of highly energetic particles and a mystery unlike anything we have seen before. Voyager 1's journey began on a clear September morning in 1977. Designed to study the outer planets, it provided humanity with close-up views of Jupiter's swirling storms and Saturn's majestic rings. But once those initial encounters were complete, mission controllers steered Voyager toward an even grander destination, the edge of the Sun's influence. For decades, it has been moving steadily outward, crossing first the termination shock, then navigating the turbulent Helios sheath, until in 2012 it finally passed through the Heliopause, the invisible frontier where the solar wind's push is balanced by the interstellar medium beyond. Voyager 2 would follow 6 years later, but Voyager 1 has always been a little ahead, carving a path into unknown territory. The latest readings from its instruments have revealed a remarkable find. In the space just beyond the Heliopause, Voyager 1 detected plasma temperatures far hotter than expected, in the range of tens of thousands of degrees. But the heat here is not like the warmth of sunlight or the searing burn of fire. Instead, it is a measure of particle speed, of how fast individual electrons and protons are racing through the void. In this environment, the density of particles is incredibly low, less than 1 per cubic centimeter, meaning that even though each particle carries a huge amount of kinetic energy, there is not enough matter to transfer that energy to a passing object. In practical terms, Voyager is flying through a furnace in which the flames are too sparse to cause harm. These conclusions come from an array of sophisticated instruments, each designed to interpret the invisible signals of space. Voyager's plasma wave subsystem listens for the faint oscillations of electrons, from which scientists can determine the density of the surrounding plasma. Its magnetometer senses the strength and direction of magnetic fields. Low-energy charged particle detectors record the number and energy of protons and heavier ions striking the spacecraft. By combining this information, mission scientists can calculate the average velocity of the particles and from that, derive an equivalent temperature. It is a temperature that describes the agitation of particles, not the warmth of an environment as we experience it on Earth. What makes this firewall truly fascinating is its connection to the Sun's magnetic reach. For decades, researchers believed the solar and interstellar magnetic fields were separate, with a sharp transition at the Heliopause. But Voyager's measurements tell a different story. The magnetic field on the far side of the Heliopause is still aligned in a similar direction to the field inside the solar system, as if the Sun's influence drapes across the boundary and blends with the magnetic fabric of the galaxy. This unexpected continuity suggests that the Heliopause is not a rigid border, but a dynamic, permeable region where solar and galactic forces interact. The structure surrounding the Heliopause is far from simple. The firewall appears to be one feature among several. There are layers of compressed plasma, magnetic barriers, and waves of energy driven outward by solar storms that can take over a year to reach the edge of the heliosphere. Some scientists suspect that the firewall's intense particle speeds may be caused by these shockwaves, merged interaction regions where solar wind bursts collide and pile up against the interstellar medium, compressing and heating the plasma. Others believe magnetic reconnection events, where solar and interstellar field lines snap and rejoin, could also play a role. Whatever the cause, the firewall is not uniform. It may change with time, grow stronger or weaker, and shift depending on the sun's activity. Despite passing through this region of extreme temperatures, Voyager 1 remains unharmed. The secret lies in the nature of space itself. In Earth's atmosphere, heat is transferred efficiently because molecules collide constantly. In the near-perfect vacuum around Voyager, collisions are vanishingly rare. Even though each proton or electron that strikes the spacecraft is moving at tremendous speeds, there are so few of them that they cannot collectively raise the probe's temperature. It is the same reason an incandescent particle in a particle accelerator can be at millions of degrees without melting its container. There simply isn't enough matter to pass on the heat. Voyager's survival is also a testament to its engineering. Built in the 1970s with robust, analog systems, it was designed to endure radiation belts, solar storms, and the cold of deep space. Power is now critically low, forcing engineers to shut down some instruments to keep others alive. Each command from Earth takes over 22 hours to reach the spacecraft, and another 22 hours for its reply to return, a 44-hour round trip for every adjustment. Yet despite these challenges, Voyager 1 continues to operate, carrying our curiosity further than any other machine. The Firewall discovery raises profound questions. How far does the sun's magnetic influence extend into the galaxy? Is the heliosphere a tightly sealed bubble or a leaky membrane that exchanges particles and magnetic energy with interstellar space? Does this boundary help shield Earth from cosmic rays? And if so, how might changes in solar activity alter that protection? Every byte of data Voyager sends back is a clue, helping us refine our models and challenge old assumptions. As it drifts deeper into the interstellar medium, Voyager 1 reminds us that space is not empty. It is filled with invisible structures, subtle forces, and hidden interactions. Our solar system is a small island in a vast galactic ocean, and we are only beginning to map its shores. This ancient probe, powered by fading radioisotope generators and the determination of the people who built it, is still expanding the edge of human knowledge, still showing us that there is always something new to discover, even in the cold, silent darkness between the stars.